Hello there, I am Dr Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Hello there. You're welcome to this series of videos we'll be having, series of lectures we'll be having on business statistics. For some time now, we'll be looking at moment, skewness, and kurtosis. When we talk about moments, we're referring to the degree of deviation of the series of data from the mean of the deviation. So we're referring to moments about the mean of a deviation. So for today, we'll be looking at one of the examples we have on moments of the distribution. Let's look at what we have on our workboard. We're looking at example 1 here, as you can see, and we'll be dealing with finding the moments of the following ungrouped data. Here the data are raw data and they are ungrouped. We have 1, 2, 3, 6, 8, 10, 15, up to 25. To solve this problem, as we said, moments measure the degree of deviation from the mean of a distribution. We must find the mean of the distribution. Then from there, we will now find the deviation from the mean. Then we'll go ahead to calculate the degree of deviation to the fourth degree. Now, you're going to know that deviation to the second degree is actually the variance of the distribution. Deviation to the third degree is actually the measure of the skewness of the distribution. Then the deviation to the fourth degree is actually looking at the measure of kurtosis of the distribution. So let's look at what we have for today. The first thing we're going to do is to draw our table to do our calculation. Then we have our x value here, and we write out all our observations. We have 2, 3, 6, 8, 10, 15, 17, 18, 20, and 25. Now, for us to do, since they are group data, we need to find the mean of the distribution. The mean of the distribution is the summation of all the observations divided by the number of observations. So right here, I am going to place, this is the sign for mean, and the mean is summation of x over n, the number of distribution. Now, if we add this, can you do that with me using your calculator to sum these values with me? Can you do that quickly? For what I have here, if you add up all this, you are going to have 124. 124, that's the summation of all the values. And how many are they? They are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have 10. So that gives you 124 divided by 10 will give you 12.4. That's our mean. Now the next thing we do is to find the deviation of this distribution. And the deviation is given as x minus x bar. So that will be each of these observations. We deduct the mean from each of these observations. So this one, 12 minus 12.4 will give us minus 10.4. Have you done that? Thank you. So let's move on. The next one, 3 minus 12.4 will give us minus 9.4. The next one will give us minus 6.4. 8 minus 12.4 will give us minus 4.4. The next one, 10 minus 12.4 will give us minus 2.4. Then we have 15 minus 12.4 will give us 2.6. Then the next one, 17 minus 12.4 will give us 4.6. The next one will give us 5.6. The next one will give us 7.6. And 25 minus 12.4 will give us 12.6. So these are deviation from the mean, the first degree of deviation. The next thing we'll do is to have our second degree of deviation, that is d raised to power 2. And d raised to power 2 is x minus x bar all squared. So we're going to square these values one by one and we produce the answers here. Now to do that, if you square this, that's minus 10.4 raised to power 2, we're going to have 108.16. I'll supply the rest. Please do that at home as you're going along with me in these lectures. The next one is 88.36. 6.4 squared will give us 40.96. The next one is 19.36. The next one is 5.76. The next one is 6.76. The next one is 21.16. The next one is 31.36. The next one is 57.76. The last but not the least is 158.76. So this is the second degree of deviation. We now go on to calculate the third degree of deviation. The third degree of deviation, that is d raised to power 3. Now, to get what the values of d raised to power 3 will be, we will simply, you either have this in your calculator, minus 10.4 raised to power 3, or you simply multiply these values by these values. Now look up here, if you have d times d raised to power 2, according to the law of indices, you have 1 here. So d, you have d, and 1 plus 2 will give us 3. That's why we will multiply these values against these values. So let's do that. Can you do that with me very quickly, wherever you are? Now, mind you, if you have minus times plus, you are going to produce a minus here. So don't make a mistake. We have minus 1124.86. That's the first one. The next one is minus 830.58. The next one is minus 262.14. The next one is minus 85.18. The next one is minus 13.82. Then we have this one, will give us 17.58. The next one is 97.34. The next one is 175.62. The next one is 438.98. Last but not the least is 2000.38. Now take note that I have maintained 2 decimal places. Depending on the calculators that you are using, restrict yours to 2 decimal places so that you can have the same values as I have. The next thing we do is to now do the deviation to the 4th degree. That is d raised to power 4. D raised to power 4, how do we get the values for d raised to power 4? For d raised to power 4, it will be the values of d here multiplied by the values of d raised to power 3, just as we did up here. So d times d raised to power 3 will give us d raised to power 4. Can we do that together? Now, what will these values give us? Can you try that? This on your own. Can you do that with me? Okay, let me shift to this side of the board. So what we're going to have is 11698.54. That's what we have there. The next one is 7807.45. The next one is 1677.70. The next one is 374.79. The next one is 33.17. The next one is 45.71. The next one is 447.76. The next one is 983.47. I trust you're doing that with me. Make sure you're using your calculator to confirm these figures. The next one is 3336.25. Then the last one is 25,204.79. Now we have the deviations, the 1st degree deviation, the 2nd degree deviation, the 3rd degree deviation, and then the 4th degree deviation. The next thing we do is to sum these values to find the summation of each of the deviations. So we'll do that right here. I'll put my summation sign here. Now, if you sum this, your 1st degree deviation should result in 0. Your 1st degree deviation should result in 0. There's no movement from the deviation, so it results in 0. Now, the second one, 2nd degree, if you sum that, what I have in my solution here is 519.04. Now, sum this quickly too. The 3rd degree, the summation is 413.32. Then this last one is 51609.63. So these are the summations of the deviation. The next thing we'll do at the other side of the board is to calculate the moments of this distribution. So up here, I'm going to write moments. I'm going to write moments. And so the first moment is given by mu1, and the formula is summation d all over n. Summation d all over n, and that will give us summation d all over n is 0. So this will be 0 all over, what is our n? Our n is 10, and that will give us what? That will give us 0. Now the second moment is giving us summation d raised to power 2 all over n. Summation d raised to power 2 is 519, that is 519.04 all over 10. And what will that give us? to give us 51.9. That's our variance. Then we have the third moment, which is giving us summation D, which is power 3 all over n, and that will give us, this is what we have. We have 413.32 all over 10, and that's going to give us 41.3. Okay, then we have summation. Now we have our fourth moment. Fourth moment is summation D, which is power 4 all over n, and what we have is 51,609.63 all over 10, and our answer there is 5160.96. All right, you can see from the board, the first moment is giving us 0. The second moment resulted in 51.9. The third moment showing the skewness, slightly skewed, seeing all the big values on one side, that's what it's showing. Then this is the fourth moment of the distribution. Thank you very much. If you have any comments on this video, you can put a word or two at the end of this video. Thank you.